the Newton's second law in terms of angular momentum, not linear momentum, by analogy. This is, the net external force is what? dP over dt. What will be sigma tau? By analogy. The derivative of what? What is P? Linear momentum. This is analogous to tau in rotational motion. F is analogous to tau. P is analogous to what? Angular momentum. So what will be the derivative of what? dL over dt. But what is L? As we know, L is this, so will be the derivative with respect to dt of L. Will be R cross NV. R cross NV. And what is the derivative of a product? R and V. Mass is a scalar and mass is constant. But V not necessarily is constant. If we find the derivative of this product, how do you find the derivative of a product in calculus? The derivative of what? No. Product. Product rule, right? The product rule says that is the derivative of the first, right? Cross the second. Plus the first cross the derivative of the second. Is that right? According to calculus. So, what is dr over dt? According to physics, what is dr over dt? The derivative of position with respect to the time. Velocity. And if we cross product the velocity with the velocity, which they are parallel, and it's a cross product, which is sine of theta, what will be the vector, or what will be the angle between the velocity, or which is the same momentum, and the velocity? What will be the angle? The angle between velocity and mass time velocity. What is the angle? 0 degree. And if it's sine of 0 degree because it's a cross product, what will be this element? This element. This is velocity. Time cross product times the velocity as well. The angle is 0. This is 0. This vanished. And we get R cross what? What is D? D over dt. P is correct? So R cross P, from here, this equation. Which I said originally, angular momentum is just this. But I didn't explain. This comes from here. So angular momentum from now on will be this. What will be the angular momentum when an object is purely rotating? Let's say we have an object purely rotating, and necessarily this will rotate and also precisely, like precession. So not this, but this. This object is purely rotating. If I know omega, the angular velocity, what will be the angular momentum? By analogy. First of all, if we have R cross P, will be R and V. Let's say that this object is moving like this with momentum and V, and this is the radius. Is that right? So if I know that this will be the formula, R cross P, what will be R, the radius, N, the mass, B. What is B in terms of omega?
B over R. Or I mean,
B in terms of omega.
that's omega R.
Omega R. So what is this? M R times R? R squared. MR squared times what? Omega. And what is MR squared for a particle? I, the moment of inertia. So what is L in terms of omega? I times what? I times what? I times what? Omega. Is this analogous to this? Momentum is analogous to L. M is analogous to I. And V is analogous to omega. Can you see that angular momentum have the same formula for an object purely rotating? This is the definition of angular momentum for an object purely rotating. I omega. But what about if the net torque is equal to 0? What will happen to dl, the derivative of angular momentum? If the net torque is equal to 0, what will happen to dl? dl will be what? If the net torque is 0, I multiply by dt, what will be? 0 times dt. 0. The derivative of L is 0. When the derivative is 0? When the function is constant. What is the meaning of that? That L has to be constant. And if L is constant, what is that? What did we study here? Pi is equal to P final, right? So Pi is equal to P final is constant because the net force is 0. Now, because we are in rotational motion, we have to say if the net torque is 0, we get that L is constant. And L constant means Li is equal to L final, which is the law of conservation of angular momentum. For example, let's say that I have this. I put this object. Let's say that this is a disk. It's rotating. So what will be the angular rotating at constant angular velocity? Omega. What will be the angular momentum of this at this moment? According to this formula. I. What is I? What is that type of object? A solid disk. Mr squared. 1/2 mr squared. Sorry. Omega initial. What will happen when I put this and there is no net force? Because the only force acting will be the force that this is acting on this and this is acting on this. So what will be the net force? If it's by the action and reaction law, those forces cancels out, correct? So if I put this here now, what will happen to the angular momentum? The moment of inertia increase, right? If to be constant, the angular momentum to be constant, if I have that Li is equal to L final, in this case, I, omega I, has to be equal to I final, omega final. At the beginning, the moment of inertia was bigger or smaller? Now, we have two objects, we have one object. The moment of inertia, when I put the two objects, will increase or decrease? Increase, because two objects, I have to add the moment of